So के हुँदैछ भने so I was talking about the third factor, right? So third factor is angle of prism. So just remember, this is not there in the syllabus, not that important. So angle of prism increases with increase in, no, when angle of prism increases, it'll increase the angle of deviation. Okay, you just remember this. And fourth one is the important part, color of light. You guys can hear me, right? Hello?
Yeah.
Yeah, color of light. So what happens is, now what you need to know about this is, a beam of white light, is not white basically, right? It is a combination of 7 colors. So it is a combination of 7 colors: V I B G Y O R: violet, indigo, uh, blue, green, yellow, orange, red, right? So these are the 7 colors that make up white light, right? And these colors have different velocities and they behave differently in transparent medium. So what happens is, so whenever we consider the wavelength of wavelength of these colors, and how it affects the refractive index of a medium. Refractive index of a medium. So we consider the wavelength of these lights and consider how the wavelength of these lights affect the refractive index of a medium. Now we know that for a visible light, violet, indigo, blue, green, yellow, orange, red. So it goes this way and the wavelength increases. Wavelength increases as we go from left to right in this series, right? So the wavelength of violet is lowest as compared to wavelength of red in the spectrum. So wavelength of violet is lowest, and wavelength of red is highest. So you know about the wavelength, right? What is wavelength? Wavelength is the complete complete wave path taken by the light or any electromagnetic wave to travel. So wavelength of a sinusoidal wave is complete distance. So this entire thing is the wavelength. If you measure it this way. So this is the wavelength, right? So for the 7 colors of white light, that is violet, indigo, blue, green, yellow, and orange, the wavelength of violet light is the lowest, and the wavelength of red light is the highest. And we should know that when wavelength increases, the refractive index decreases. So for a higher wavelength light, the refractive index will be lower. So let us assume that. So you should keep in mind about this fact, okay? This fact should be in your mind. So when wavelength is higher, the refractive index will be lower every time. So when wavelength is higher, the refractive index will be, one second. So when the wavelength is higher, the refractive index will be lower every time. So just remember this fact. So whenever there is higher wavelength, its refractive index, the refractive index will be low, which means a higher wavelength light will refract less than a lower wavelength light. So you should be able to infer after studying all these. So when wavelength is high, refractive index is low. Matlab, the highest wavelength, so which one is the highest wavelength? Red one will undergo the highest refraction. I mean the lowest refraction, because this has the highest wavelength but the lowest refractive index. So since red has the highest wavelength but in turn will have the lowest refractive index, red will be the least deviated. And violet being the one with the least wavelength is least, so the refractive index will be the highest. So violet will be the maximum refracted and red will be the least refracted. So you can say that angle of deviation of violet will be greater than angle of deviation of, let's say, green, middle of the spectrum, is greater than angle of deviation of red. So what is not clear from this part? Let me know.
मैले सबै बुझेँ कि तर
Yes.
मैले यो त्यो बियरको नि उ त्यो चाहिँ कसरी चाल पाउनु भयो रिफ्र्याक्टिभ इन्डेक्स चाहिँ हुन्छ कि रेडको यति हो उतिको भनेर
Yes, यो छ नि
अन्तर
त,
गर्दाको
एउटा रिलेसन छ नि त. For a transparent medium, so any transparent medium like glass or air, right? So any transparent medium, the increase in wavelength will decrease the refractive index. So this is the known fact you should know every time. So this is a very important fact you need to know. So whenever there is increase in wavelength, the refractive index will decrease. So as we go from left, and the बुझे है ना? So now if you, okay, so if you do something like this, let's do so this was there previously. I didn't do that part when prism was taught. So I was waiting for this topic to complete, and then I wanted to do this. So let's say this is a prism now, and there is an incident ray coming like this. So there is a white incident ray. Is there a white color here? So we have a white incident ray coming. This is yellow. So we have a white incident ray coming, right? And that thing is getting refracted, so to some degree. Now let us assume that colors are emitting here. Now we don't see white light here. Let us assume colors are coming here. So which color will be here? Which color will be here, and which color will be here? Can anyone tell me? So if this is the normal now, if this is the normal,
violet
violet कहाँ हुन्छ? Yeah, I don't think so. Let me verify.
deviate हुन्छ हैन?
Violet will be the maximum deviated, right? So maximum deviate भनेको कहाँ हो? माथिको मुनिको? So maximum deviation भनेको angle should be maximum. So which angle is greater, this angle or this angle?
तलको त्यसो भने तलको.
So this one will be violet, and this one will be red. So it'll be something like, I don't have violet color. I have red though. So this one becomes red, because red is the least deviated, and this one will be the violet. I don't have violet color. So G, I have green. So green will be somewhere in between here, right? So I just want to verify this. I think it's correct, but I want to verify it. I don't know where to find this, but most probably this is correct.
Google मा हेर्नु न, Google मा आइहाल्छ त.
Oh yes. I'll show you guys as well. If I'm wrong, I'll correct myself. What is this? Setting off white light in prism. Yes, so violet is the one that is in the most deviated. So I did the same thing, right? So I said violet is the one here, and red is the one that is at top. So where is that one? So red is at top, green is somewhere in between. So exactly green is in between. So you should know this, okay? So the main thing you need to take away, the main takeaway from this is, you don't need to remember this diagram. You can derive this diagram if you know one small factor. So that small factor that you need to know is wavelength and how it affects the refractive index, right? So when wavelength is high, refractive index is low. That is it. So just understand it. Wavelength is inversely proportional to refractive index. Just remember it this way. It is not totally correct, but the best way to remember is, when wavelength is high, this refractive index will be low. So for the color of light which has the highest wavelength will refract the least. Like for red has the highest wavelength, right? So it will refract the least. So it has the least refractive angle. So it has the least angle of emergence. So this is the angle of emergence of red, and this is angle of emergence of violet. So angle of emergence of red is very much lower than angle of emergence of violet. So is it clear, this part?
Yeah, totally.
How wavelength is dependent on refractive index. So this is basically the end of this part of the chapter, and after this is complete end to prism. Okay, so we don't have prism from now on. We'll just have apparent depth, real depth, application of refraction, and then we have critical angle and total internal reflection. I think that's the last topic in this chapter, and after that we have lenses. So, yeah, that is the other chapter. So we just have 3 more topics left. Very simple: apparent depth, real depth, then critical angle, total internal reflection. 4 topics. So we'll complete it by next 2 classes. So if this is clear, you guys can leave. Okay. So if you have no doubts, you can leave.